All right, so we got ourselves going on chapter 3, dealing with fractions and decimals. So let's try one that's maybe a little bit more interesting than the 5/16. Let's try something like, let's go with 3/400. Again, let's convert this into a decimal. And remember, folks, please remember, first test, half of the first test is no calculator. So I could ask you to convert this to a decimal, and you have to be able to do it without a calculator. Yes, I know you can pull out your calculator and punch in 3 divided by 400 and do it, but make sure that you can do it by hand if necessary as well. So, what do we do to convert this into a decimal? 5. Good old long division. What do I divide into what? How do I write it? And what am I going to do so that I can actually make this work? Put in zeros, right? Add in as many zeros as you think you might need. Now, hopefully that's too many zeros, but we'll see. All right? Now, remember that the decimal point is like, like the duck after you shoot it, right? When it falls into the ocean, or the lake, it'll come back up. Decimal point always goes right where it right where it is, moves right up on top. Now, the key to this, folks, is being careful, because technically, how many times does 400 go into 30? None. You need that leading zero, right? 400 cannot go into 30. Can 400 go into 300? You need another zero, okay? Now that you've gotten rid of the first two zeros, or essentially made it past this stage, now we're looking at how many times does 400 go into 3,000? 7. And again, since we're dividing that 400 into 3,000, the 7 goes over essentially the number 3,000. All right? 7 times 400. 2,800. Subtract 200. If you don't have a remainder of 0, always drop 1 0 down, folks. You always get 1 0 free going down. How many times does 400 go into 2,000? Nicely enough, 5. And 5 times 400. And there is the decimal representation of 3/400. 75 10,000ths. And again, folks, you can check with your calculator, right? So when you convert your fractions to decimals, if you're doing this on the homework, I strongly encourage doing it by hand first, and then get out your calculator, and after you're done, quick like, punch it in and go, oh yeah, 0.075, 3 divided by 400, 0.0075, sweet. All right, make sure you don't miss the points, but make sure that you can do it by hand, okay? Invariably, students come to the test, and they're like, oh, I always did this with my calculator, and now I don't have it. Duh. Please practice this, okay? That's all I'm asking. Alright? Alright, so that one's not too terribly bad. Now, how about this one? If you know the answer to this, yes, you will chuckle a little bit to yourself, and that's fine. Realize that my mom asked me this question when I was about 7 or 8, when I was first learning about how to do division, and she's like, oh, just try it. And I was like, okay. So she showed me the pattern. She showed me how you do long division. She said, great, yes, just divide 3 into 1, and now add as many zeros as you want. How many do I need?
many as you can actually write on that board.
My mom was a little bit evil. I have 4 brothers, folks, so all she had was 5 boys. My mom's a little crazy now because my brothers were even worse than I am. They're all math people too, every single one of us. Anyways, enough said. So, how many times, folks, does 3 go into 10? But how many times does it go into it? 3. And 3 times 3 is 9. 10 minus 9, 1. Drop down to 0. How many times does 3 go into 10? This is a great trick to play with the kids if you ever get a chance. Just tell them to keep going. Use as much paper as you need, right? 3, 9, 1, 0, 3, 9, 1, 0. Keep telling them. Eventually it'll turn into 0, I swear. Obviously this never turns into 0, folks. The 3's just repeat over and over and over again. How do we write that so that you can tell me that?
Oh, I know.
All right, exactly. If you like to write 2 3's and put the bar over the 3, that's fine. There's nothing wrong with it. This is just the easiest way to write it, okay? So if you notice a repeating pattern, folks, I do expect you to be able to tell me what the pattern is, okay? I really think you should be able to do it. It's not too difficult, right? So 1/3 gives us 0.3 repeating. All right, so let's try another one. Should we just jump right to the annoying one? Okay, let's jump right to the annoying one. By far, the worst number in fractions, folks, period, is 7s. Period. 7 is by far the worst mathematical fraction number to deal with. And you're going to find out why right here. Most mathematicians are like, oh, this is cool. But regular people are like, oh, God, that number sucks. So, and here's why. Let's find the fraction that this represents as a decimal, all right? So 7 divided into 2. And now let's make sure I have as much room as possible. Hint, hint, hint. And I will try and write a little bit smaller this time. Again, remember that the decimal point always goes straight up from where it is, right? Now, 7 goes into 20. How many times? 2. 20 minus 14, 6. Drop down a free 0. 7 into 60? 8. 56. 60 minus 56. 4. Bring down a 0. 7 into 40. 5, 35, 5, you get another 0, 7 into 50, 7, 49, bring down the 1, remember you get a free 0, 7 into 10, 1, 7 suck, folks, 7 into 30, 4, 7 into 20, 2. And nicely enough, folks, this is what you guys need to start doing when you're dealing with these things, right? Is now what's going to start happening, right? You can see what happened, right? We had 14, and then it became a 6. What's going to happen next? So what's the next number after that 2? 8. What's the next number after the 8? Next number after the 5? So how do I write 2/7 as a decimal? 0.285714. Sevens have the most possible number of repeating digits that you can ever have as a fractional representation of a decimal. All right? You can never have more repeating digits than the number that you have in the denominator. So 7, the most numbers that you could have repeating are 6, and nicely enough, 7. It's got the most possible. All right, 7 suck. That's all there is to it. But, again, the nice part about it is that by writing this, you get to see the patterns show up, right? Because once you get to the 20, you're like, hey, it's going to be 14, 60, 40, blah, 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 blah. And that's, again, why I like to have people be able to actually do this, so they can see it's really happening, okay? Again, you can get out your calculator and do 2 divided by 7, and it'll give you 285714286, and then we'll round the 5 to a 6. And you probably can look at that and see where the pattern is, but you may not, okay? This, you definitely see. This is why this is relatively powerful, all right? All right, so, not too bad. All right, so I like to be a little bit cautious. So I'm going to say this: round. Let's say 100. Let's say round 100 and let's go 100 and we'll make it weird. So there will be times when you actually have to create a decimal, and then you are asked, instead of actually giving me the decimal with all the repeating digits, you're just asked to round the number to the thousands. Okay? Note, when you're asked to round a decimal to a certain place marker, you do not have to figure out all of the digits. You can stop as soon as you are able to and say, oh, I know where it rounds to, boom, I'm done. Okay? So, where will I need to stop when I can, so that I can round this number correctly? Can I stop at the thousands? Why do I have to go to the next one? Yeah, see if you round up or down. Okay, so cool. All right, so how are we going to convert 120, 100, 119, 120ths? We know we don't need to go more than 5, because at that stage we've gotten to the 10,000ths and we're done. All right. So, $120 cannot go into 119. Can 120 go into 1,190? How many times? 9. Okay, good. Note, folks, that when you have a number that's really, really, really close to 1, right? If there was just one more number up here, it would be 1. You know that that number has to be close to 1, so you should expect the first digit to be 9. Okay? All right, now, what's 9 times 120? 0, 18, carry your 1, 1080. All right? Subtract. 0, 1, 1. Remember that you always get a free 0. How many times does 120 go into 1,100? 9. Remember we just did 1080, which is sort of nice, right? $20. Bring a free 0 down. How many times does 120 go into 200? 1. Am I done?
Yeah.
Almost, technically, right? You got to go 1 further. How many times does 120 go into 800? Six. Because what's 6 times 120? And do I need to go any further than that? Nope, because I was asked to round that to the thousandths. Here's my thousandths. What's the number next to it? So what do I say my answer is? 0.9924, 992 thousandths. All right? In theory, I would ask you to potentially do that kind of a question on the test. Right? And the cool thing about it is, technically, folks, what is 800 minus 720? 80. I'm going to add a 0. How many times does 120 go into 800? 6. 720. You're going to subtract it. You're going to get 80. Bring down a 0. How many times does 120 go into 800? 6. This is just 0.991666666666666666666. It's actually the repeating piece is the 6 is at the very end. All right? But if you've gone a couple more steps, you guys have been like, oh, cool, I know this one. Right? But since I asked you to round to thousands, you can always stop a little bit early. All right? All right. Not too bad? All right. So let's see. Just to be safe, how do you write that as a decimal? Okay, good. If you've got a whole number, folks, just bring along for the ride, right? And then look at the fraction, and if it's a nice fraction, so if I was nice to you guys, what is 1/4? 25 cents, so 4.25. Okay, that's one of those where it's like, I'm never sure if I have to show you guys, but I always do just to be safe. Okay? All right. Now, go the other way. What is that written as a fraction? And this is one of those times where I wish that back in grade school we were a little bit more, just a little bit more picky about reading numbers correctly. Technically, how do you read this number correctly? I know the gut response is to say 0.13, right? But that's how you read the number. How do you say the number? 13 hundredths. When you say that, folks, how do you write that as a fraction? 13 over 100, because you just said 13 hundredths, right? So by actually verbally saying a decimal out, you actually are saying the fraction for you. It's there, right? This is 13 100ths. Just write what you said. All right? And that was actually a really nice tool for me when I was first learning fractions, because I'm probably a lot like you guys. I was like, oh, decimals are so much easier. Why don't we use them? But again, once you start seeing the tie-ins, you can kind of say, oh, they're basically the same thing anyways. Why are we so pissed off about it? Now, just be careful with these. Again, so how would you correctly read that number? 5 thousandths or 5 1,000ths if you want to be really anal. And what would you do with 5 over 1,000? Reduce it. What would it reduce to, folks? 1/200. Okay, so just reduce as you convert. And what happens if there's a whole number floating around there? Yeah, 5 and 3 1,000ths. And again, because you read the number correctly, 5 and 3 1,000ths, you can just write 5 and 3 1,000ths. Now, one of the things that I like to show students, just so that you can see it, is that, notice, how many decimal points are there in that number? 2. How many zeros are in my fraction? 2. How many decimals are in this number? 3. How many zeros are in my fraction? 3. That always works, folks. All right, so technically you don't have to try and figure out where it goes to. Just go ahead and say, how many decimal points do I have? Again, note, there's 3 decimal points here, 3 zeros in your fraction. That always works. So if I give you something like 0.01001 and ask you to write that as a fraction, technically what's the number on the bottom? 1, 2, 3, 4, 5 zeros. Since there are 5 decimal places, 1, 2, 3, 4, 5. 5 zeros on the bottom. Okay? And then theoretically, all you have to do is write the number here without the decimal point. So what is this number if you were to erase the decimal point? 1001. Yeah. So that always works. Okay? That is a handy, simple, straightforward technique. Okay? Use it to your advantage. All right. See how savvy you guys are, right? I'd like to think some of you know what this is implicitly because we've kind of done it a lot of times in our lives. So what is 0.6 repeating written as a fraction? 2/3. Very good. Remember, we already know what 0.3 repeating is, right? We did that one. So I'm going to give you a little bit of a hint to lead you to my next question. I'm going to tell you that this is the same as 6/9. This is the same as 3/9. What is 0.2 repeating written as a fraction? 2/9. Why do you think it's 2/9?
Because of 0.3 repeating is 3/9, and 0.6 repeating is 6/9. If it's the same pattern, it would be 2/9.
Exactly. Noticing patterns, being able to recognize and utilize, right? So 0.3 repeating is just having the 3 over a 9. 0.6 repeating is having the 6 over the 9. 0.2 repeating? Yeah, 2/9. Get out your calculators, folks, and punch in. 2 divided by 9, what will you get? 0.222222222. Kind of cool, right? Again, noticing patterns. So, let's see. So, here, let me give you one. Let's suppose So if you want, you can get out your calculator, punch it out, and show yourself that that's true. 13 over 99 is 0.131313. The 1 and the 3 are constantly repeating, right? So what is 0.47 repeating, written as a fraction? 47/99. Notice I didn't even have to show you very much of the pattern. You could already kind of see, well, if it's building off of this one already, once you get one step, yeah, you should be able to. Interesting, right? So what am I going to do next? I'm not going to give you any hints at this. What's this? Take the pattern to the next step, folks. What is it?
be over 999 or 999.
Yeah, 467 over 999. Right? That's how it works. And so, what we can do is go back. Where did our 2 sevens go? Two sevens. Notice what it is. 285714, all repeating. Technically, what is this written as a fraction? Now that you know what the pattern is.
999,999.
Yeah, it's 285714, all over 999999. And guess what that fraction simplifies to?
2
sevens.
So anything repeating is like 99 underneath it?
If it doesn't have any leading numbers. So as long as there aren't any numbers in here that come first. So like remember that 120th one? It was 0.99166666666. If there's no digits leading, then yes, it's always over some form of 9.
Okay.
Yep. Good question. But the cool thing about this is that even though you don't know that this simplifies to that, you'd be like, how the heck? There's no way it does. But yeah, it has to, because you know that these two fractions are the same thing. All right? And again, this is sort of that full circle thing that math often does to you, whether you like it or not. It's like, okay, I see a pattern, I step forward, I step forward, I step forward, then you take a big, huge step forward, and then look back and go, oh, hey, look, it's even easier than I thought. All right? And that's what makes math often very cool and fun to deal with, at least in my mildly warped sense of reality. Okay, so anyways, there are fractions and decimals back and forth. Let's see. Okay, so how do you add decimals, folks? Line them up and down?
Zeros, like after, to make them all the same.
Right. What am I lining up, though?
The decimal.
Lining up the decimals, right. So again, invariably, folks, we will give you the problem written horizontally, and it's your job to rewrite it correct vertically, okay? So that you need to be able to say, oh, this is 1.2 plus 0.005 plus 40.22 plus 310.1 plus 4.4567. And this is where having handwriting that is relatively neat comes into play. I had pathetically awful handwriting when I was a kid. I couldn't get these numbers lined up. When I was a kid, I had a little bit of dyslexia, so these are the way I wrote numbers. My zeros were always really big, because I couldn't make a zero that closed correctly small, and so I always wrote it huge. So this is the way my zeros looked, and all my other numbers would... It's just the way I was, okay? I was a little spastic as a kid, and that was the way it worked. And so what they actually did for me back in either 4th or 5th grade is that I had to do all of my math homework on graph paper. And every number had to fit into one of those little boxes on the graph paper. And it forced me to write all of my numbers the same size. And all of a sudden I was like, oh, this is so much easier. Because you could actually see that the numbers, were over each other. Anyway, you get my point. The idea here, or one of the suggestions, not a bad suggestion, is to say, hey, make sure all of the numbers have the same number of decimals, and if you really want, you can also say have the same number of whole numbers so that you don't accidentally add stuff that you shouldn't be adding together. Okay, and that especially if you know you have problems writing too fast and writing sloppy. Okay, for me that was a huge issue. Once you get it all lined up, I'd like to think that you guys are okay with just going ahead and adding, right? So it's 7, 11, 1, carry your 1, right? 8, 2, 4, 5, 9. There's your decimal point. 5, 5, 3. All right? So again, please, when you are adding decimals, just make sure that you get stuff lined up correctly and you add accordingly. All right? All right. I don't need to do another one of those, do I? Okay, thank you. Please be careful subtracting. This is the sort of thing that I would ask you to do on a test because I'm a jerk. Just don't screw it up. Again, non-calculator type question, right? So, how do you subtract these two?
You put the correct amount of zeros after the 7.
Alright, remember that 7 has a decimal point and there's as many zeros as you need after it. So this is 7.000000 minus 2.4681314. And how do we borrow to get all those zeros so that we can subtract? Yeah. Make the 7 a 6. Remember that all of the zeros that follow are going to be 9s until you get to the last one. And that one's a 10. And if you like to go through the whole process of saying make this a 10, and then scratch it out and make it a 9, and make the other one a 10, and then scratch that one out and make it a 9, and make the next one a 10, there's nothing wrong with that. Right? So you're just borrowing one and passing it down the line continuously. And so the 10 goes to a 9, and the 10 goes to a 9, etc., all the way down to the last 10, and then you can subtract. All right? Yes? Make sense? Okay. So yes, 6, 8, 6, 1, 3, 5, and then just don't screw the last one up. 6 minus 2 gives you 4. All right? And when I do these subtractions, folks, since I know these are all 9s, I'm never actually subtracting. I'm looking at these numbers going, what number adds to these to make 9? Right? So I look at 1 and say, well, what do I have to add to 1 to get 9? 8. 6 and 3, 9. 1 and 8, 9. 3 and 6, 9. 5 and 4, 9. This is 9s. Okay? Again, just don't screw up on the last one either. The last one's always a 10. Alright. Not too bad? Now, I do like to be a little bit careful with this because this one can happen. So imagine you have $54.72 in your checking account, and you write a check for $81.64. And assume that your bank account allows you to overdraft for up to, say, 30 or 50 or 60 bucks, right? That's actually one of the things that has been happening out there in the banking industry right now, is that banks are trying to be nicer to you. It used to be back in the old days that if you did this, the check would bounce, you'd get dinged with a $20 check cancellation fee, etc., all that fun banking fun, enough said. Today's day and age, folks, banks actually accept negative balances for up to a 2 or 3 day span, and they don't penalize you for it. It's actually a standard feature on most checking accounts, in fact. And as long as it gets to positive within 2 days, within 48 hours, they won't charge you a thing. And so if you know, right, that you're going to get paid tomorrow, but you need to make this payment today, it's nice to say, well, even if they cash this $81.64 check, I'm okay, right? Now, a lot of times you like to write the check and kind of go, well, if I mail it, it'll take 2-3 days to get there, And then I know they won't have cashed it, and I'm safe, right? I mean, you don't have to worry about that anymore. All right? So, how would you subtract these two? Again, non-calculator.
I would actually subtract the 54 and 7200s from the 8164.
Exactly. You actually do the problem backwards. Okay? You actually say, oh, this is going to be $81.64, and I'm going to subtract $54.72. And do the subtraction normally, right? So 4 minus 2 is 2. 6, can't take 7 from 6. Borrow, make that a 16. This becomes a 9. You can't subtract here. Borrow, make that a 10. 6, 7 minus 5 is 2. And then what do you do with that 2692 at the end? Make it negative. Right, good. Why does that work? That sure seems like magic to me. Why does it work, though?
It's the same difference.
It is the same difference, but why is it? If someone asked why, right? I mean, if your kid came up to you in 4th or 5th grade and said, well, why do you do that? It used to be that whenever we did subtraction, they told us if you changed the order, you screwed up the answer. Why does it work?
It just
This is
doesn't.
like adding 54 minus 7 to negative 8.
Essentially, that's absolutely right. You're basically saying that this is 5472 plus negative 8164 and treating it the same way. All right? The real reason behind it, folks, though, is actually because you're applying algebra before you know it. This is actually what you're doing. If you subtract two numbers, it is the same as taking the negative of the numbers reversed. Think about distributing this negative sign. What does it become if you distribute this negative sign? The negative hits the b, that's a minus b. When the negative hits the minus a, what's negative a? Positive a, so it's negative b plus a, which is the same as a minus b. And they teach kids this back in like 5th or 6th grade, way before they have any algebra. But they should really show you this first, because this is more important. Because this is why this works, okay? When you switch the order, you know that you're just going to get the negative of whatever it is the result that you are going to get otherwise. Again, it's okay. I want to remind you guys that this is the way it works and this is how it happens, because I have been known in the past to ask a question like this on the test, the non-calculator portion, right? You actually have to get a negative balance on your checking account and be able to deal with it to some degree, right? All right, so just be careful and remember this little itty-bitty tidbit of algebra, which we will get to next week when we do algebra, okay? All right, so not bad? Okay, cool. So if we can add and subtract, what do we have to do next? Well, let's multiply first, if you don't mind. So when you multiply decimals, what is 12.1 times 0.47? How do we multiply decimals if you don't have a calculator,
Go
folks?
with the decimal and then count how many numbers there are.
All right, so the first step is multiply the two numbers where you completely ignore the decimal. Okay? How do we do long multiplication old school? 7 times 1 is 7, 7 times 2 is 14, carry your 1, 7 times 1 is 7, plus 1 is 8. Remember that when you're multiplying by the 4, it's really 40. And that's why you always put a 0 down there, because 40 times this number is 4,840. Add your numbers. then go back and count your decimals. Count total decimals. And put decimal back in. So how many decimals are in this number?
3.
1.
1. How many decimals in this number?
2.
2. What is 1 plus 2? 3. That's the number of decimals you put in your answer. So you will go, oh, here's the decimal point, 1, 2, 3. The product of those two numbers is going to be 5 and 687 thousandths. All right? Not bad. Let's do another one just to be safe. You guys made me a little nervous on that one. All right, so let's do 1.04. It's a 4, I swear. Times 0.025. Again, ignore the decimal points like they're not there. So this first number, instead of being 1.04, just think of it as 104. This second number, think of it, instead of thinking it as 0.025, just think it as 0.25. Now, do I need that leading 0 when it's no decimal point? No. So this is the same as multiplying by just 25. Okay? That 0, I mean, you can put it in there if you want to, but all it's going to do is make you add a whole bunch of zeros. If you add zeros, folks, what happens?
0.
Yeah, exactly. Nothing. So don't give yourself more work. All right? So multiply. 5 times 4 is 20. Carry your 2. 5 times 0 is 0. Plus 2 is 2. 5 times 1 is 5. Again, remember you're multiplying by 20 so that this leading 0 is there. And 8, 0, 2. Add. 0. 0, carry the 1. 6, 2, 6. Don't throw these zeros away. They are part of the number, okay? You can throw them away after you're done if you need to, but you don't have to, right? So, how many decimals in this number? 2. How many decimals in this number? 3. What's 2 plus 3? 5 decimals. So start here at the far right-hand side and give me 5 hop decimals, right? 1, 2, 3, 4, 5. What do I need here to lead? A 0 out front, okay? So that 1.04 times 0.025 is really 0.026. And you can, if you want, write the last 2 zeros, but that's redundant. There's no need. All right? So again, this is you're just trying to make sure that you don't run into snafus when you're dealing with these sorts of things. Note that the number of decimal points may create these leading zeros. Don't miss it. All right? All right. Not too bad? All right. I will not be mean, folks, and give you some 4-digit number times some 3-digit number on the test without a calculator. This is as bad as it will be on the test. Okay? It's a 3-digit number times the potentially 3-digit number. That's as far as I would go. All right? And I want you to be able to show me that you know how to do long multiplication, but I don't want to kill you in the process. Okay? So, I'm mean, not cruel. All right. All right. So, we good with multiply? So we got to be able to divide. All right. What is let's see. Let's start with something relatively straightforward. What is 1.24 divided by 2.5? So, again, this is a question that I asked on the non-calculator portion of the test. You need to be able to do this without a calculator. How do we divide decimals? Move the decimal over. Now, first off, how do you write this division? Which one goes outside the house? Which one goes inside the house? 1.24 is outside, so it's 1.24 divided into 2.5.
It's the other way.
Strike that, reverse it. Good. So please note whatever you're dividing by goes outside the house. This is what you're dividing into, so this is what's inside the house. And the key to dividing decimals, folks, is that you don't. You always divide by whole numbers, right? So the key is whatever number is outside the house, convert it to a whole number by moving the decimal once. However many times you move the decimal outside the house, you have to move it inside the house the same amount. So this is really 25 divided into 12.4. Okay? So here's your decimal point. And now we do regular old division, right? So can 25 go into 12, folks? No, right? So there's no whole number. Can 25 go into 124? Yes. How many times? 4. 4 times 25 is 100. Remember, you get as many zeros as you need. How many times does 25 go into 240? Last but not least, how many times does 25 go into 150? Six. And here's our result. 1.24 divided by 2.5 is 0.496. So, that moving the decimal thing. What the hell? How does that work?
It just does.
Is it more of this goddamn math magic crap, right? Technically, it's not, folks. All right? The key is thinking about this division written as a fraction. Right? That's how you would write that as a fraction. 1.24 over 2.5 or divided by 2.5. Multiply by 10 over 10. What's 1.24 times 10? 12.4 over 25. And what do you notice I just did? I moved both decimal points 1 unit. So it's not magic, folks. It's just applying the rules of math that you guys already know, right? Basically, we said multiply by 1, but write 1 as 10 over 10. However many decimal points you have in the denominator, that's how many zeros you need in your denominator. Put the same number on top. It's all just simplifying fractions. That's all there is to it. All right? So it's not magic. It's just math. Right? It's one of those things, though, where you're like, well, they didn't probably show you why it worked when you learned the first time. Again, another one of those things that bothers me. It's why whenever I teach a class that has mostly early childhood education people in it, I stress things like this so that when you get to those stages, you remember that you did this so that when you show it to the kids, you're like, kids, no, it's not magic, I swear. Even though, yes, I pulled a rabbit out of my hat, right? I mean, all right, so anyways, let's try another one just to be safe. Let's try, how about 12.7 divided by 0.02. So again, when you're doing these divisions, folks, be careful. What you're dividing by goes outside the house. What you're dividing into goes inside the house. Move the decimal point for 0.02. 2 times. Do the same thing inside the house. 1, 2. Please note when you move the decimal too far, you're creating zeros. Now you're just dividing 2 into 1,270. How many times does 2 go into 12? 6. How many times does 2 go into 7?
3,
And how many times does 2 go into 10?
5.
And nicely enough, do I need any decimals on this particular answer? No. Straight up, 12.7 divided by 0.02. 635. All right? Not bad? All right, so, let's see. Just to be safe, let's take 1.19 divided by 12.1, and I want you to round to, let's keep it simple, hundredths. So note, you do not necessarily have to finish the division in this particular instance. You just have to get to the point where you know how to round to the hundredths. Okay? So how are you going to do 1.19 divided by 12.1? Move the decimal 1 time. So we only move the decimal 1 time on the inside. Note that makes the decimal move right up between the 1 and the 9. Get as many zeros as you need. How many times does 121 go into 119?
0.
It does not. The first number is a 0 in the 10th place, right? How many times does 121 go into 1,190?
9.
Good guess that it's 9. 9, 18, carry your 1, 10. If you got to write 121 times 9 off to the side, that's fine. Do it. All right? If you can do it in your head, that's great. Subtract. You get 1 free 0 down here. We have to go 1 more place. We're already at the hundreds, but we need to go 1 further. What is this? 8. 8, 6, 9. Note, you don't need to go any further. Technically, what does this round to the nearest hundredth? Okay, good. So this is approximately 0.10. Please note, folks, when you are asked to round a number to a specific place marker, you must always write it to that place marker. Okay? So the answer to this problem is also 0.1 without the 0, but technically you haven't really written it properly because you didn't round to the hundreds, which is what the problem asked. Okay? So if there are zeros at the end when you are rounding, please write them to where you need to round and then stop. Alright? I wouldn't mark you wrong if you wrote this as 0.1. I would probably just write a frowny face next to it. And then give you all the points anyways. Okay? Just so that you know. Because it's not wrong to write it as 0.1. It's just that it's not completely correct when you write it as 0.1. Okay? So, anyways, it's like when you ask somebody to write money, and they write the money like this. That's just wrong, right? That's not money, right? I mean, it's not wrong, right? Because you know it's implied that it's 40 cents, but it's like,
When you do it on a calculator, you do it that way.
yeah, I mean, the calculator will show it to you that way. But you should be smarter than the calculator, right? And so when you get done, I want you to...
0.
Again, since this is a math class, I can sometimes relax about those things a little bit, but realize that this is a math with business applications class, and when the business people find out that I gave you credit for this answer, they get mad at me, actually, because they want me to mark it wrong. Because this, to them, is wrong. The business people, they throw a fit if they yeah, I mean, it does look weird. I mean, again, it's just one of those things that it's not wrong in this class, but everywhere else in the universe, everybody else is going to be pissed off. So, just write it out with us. Okay? Alright, so, let's see. We can add, we can subtract, we can multiply, we can divide. Alright, so. Oops. So I can either go to the Pick and Save and buy 8 hot dogs for $2.25, or I can go to Costco and buy 21 hot dogs for $5. What am I going to ask?
Better than that.
Yeah. Which is a better deal? How are you going to figure that out?
Figure out what each hot dog costs.
Okay, find out what each hot dog costs separately. So how do you do that?
There's 2.
How do I do it? Division, yes, but which way do I divide? Because if you do it one way, you will get the wrong answer. If you do it the other way, you will get the correct answer.
25 divided.
Yes, okay. So find dollars per hot dog. And note that this word is one of those math words that you should know what it means. As soon as you see the word per, you should know that it means divide. And whatever comes after it is what you are dividing by. So the key here, folks, is to take the money and divide by the number of units, not vice versa. Okay? If you do it the opposite direction, you get the exact opposite answer always. Okay? So, what is 225 divided by 8? And folks, feel free to use your calculator on this one. And since we're dealing with money, round me to the nearest penny. So how much does a hot dog cost from the Pick and Save? Which is also the Piggly Wiggly. They all own the same thing. also round these. 28 cents per hot dog from Pick and Save. How about from Costco? And note, folks, which one's a better deal? Note that I had a student one semester who told me, oh, well, the 28-cent one's a better deal. And I was like, what? Why is the 28-cent one a better deal? And her answer to me was, well, I own the grocery store. I want you to pay more per hot dog than otherwise. I couldn't help but laugh and say, oh, okay. And I gave her credit for it. Because I mean, that's not a wrong answer. If you're the store owner, right? I mean, you know, in theory, you may think that you actually paid the same per hot dog for each package when you bought them from the suppliers. But then when you go to sell them to the customers, well, of course you want to sell the ones that are going to make you more money. So. But yes, in normal circumstances, folks, please tell me that the 24-cent per hot dog purchase is a better deal. Okay. Then these might even be relatively close to reality too. For all I know, it's been a while since I bought hot dogs. All right, not bad. All right, so word problems, folks. Those are the sorts of things you got to be able to handle. Anybody know?
A lot.
Well, yes, a lot is a
It's
correct
in
answer.
trillions.
It's in the trillions. That's a very good answer too.
3.
Oh, I wish it was only 3.
Isn't it like 20?
Yeah, I was gonna say
20?
20 something.
How would you guys find out?
Look it up on Google.
Hey, great idea. Does anybody have Google with them?
Like,
I mean, I don't have that person with me, so I can't ask you. How would you do it? Thank you. You would get out your phones and say, hey, Google.
my phone is-
Normally, I discourage the use of phones in class, but this is a good question, so let's look it up really fast and come up with an approximate answer. All right? It should be something like 20 or 21 trillion or something
It
like
doesn't
that.
even actually give me a number. Hold up, like a Wikipedia page. Hold on. According to Wikipedia page, it's like 21.3.
21.3 trillion? Okay. $21.3 trillion.
I don't understand. Can I ask you a question? I'm going to ask about that. When it says 21.3
Uh-huh.
trillion,
Uh-huh.
that confuses me because where's the cents? Is it 3 a cent?
Oh, no.
That's what I don't
Okay, so how would we convert this to a real number, folks?
3 would be the billions number.
Yeah, the key to this one is that when you have one of these letters after it, it's telling you the numbers before the decimal are in this place marker.
Okay.
So this becomes 21 trillion, and it becomes a comma, and then any numbers after the decimal you just copy down after the comma, and then you fill in zeros until you get to 0, right? So these are trillions. What comes after trillions? Billions. What comes after billions?
Millions.
Millions. What comes after millions? Thousands. What comes after thousands? Hundreds. Okay. So this is really $21.3 trillion. Or $21,300,000,000,000,000,000. No, we didn't get to the cents because that's too many numbers. Alright? Now, how many U.S. citizens are there? Again, let's approximate. So some Google U.S. citizens.
In 2016, there was
322 million. So how many more? That was like, what, that's 2 years ago? So let's say like 350 million U.S. citizens. So we'll add a couple of million to make up for 2 years worth of reproduction in the U.S. All right? Now, what am I going to ask? Yeah, exactly. How much does each person own?
Yeah, nothing.
The reason you need to know this, folks, is because next election, I am running for president.
Oh,
And the platform that I'm running for president on, there are two things. Two things and two things only. One, free technical college education. And two, eliminate the national debt. Okay? That's it. You ask me anything else and I'll be like, I don't care. I'll let Congress or the Senate decide those things. These are the two things I give a crap about. That's all I'm going to deal with. Okay? 21.3 trillion. And then free technical college, right? So sort of a merger of the two parties put together, right? So the Republicans are constantly saying we're too far in debt, we're too far in debt, we're too far in debt. And the Democrats are constantly saying we need better education, we need people to be educated, give them free education, blah, 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 blah.
free education, who would pay the teachers?
Well, the teachers are all getting $1 million salaries, period. That's all.
How is that going to happen?
Well, because they're teachers.
They
Who's
work
gonna
for Congress.
pay that? There you go.
What are they doing? Like once a year.
All right. So, anyways, but if you guys ever start asking me how I do that, I'll always start talking about something else, right? I mean, the way politicians do it right now. If you ask them a hard question, they'll answer with something that's totally not related to the question, right?
Yep.
So when you ask, how are you going to pay for that all day? I'll say something along the lines of, oh my goodness, look over there. There's foreigners crossing the border and they're not American citizens, right? Right? And then the next time you say it, I'll be like, oh my God, look over there. There's a woman breastfeeding in public. Oh my God. Right? You know, and there'll be an uproar and everybody will be screaming and yelling and they'll forget what question they asked initially and, you know, it'll be like politics as usual. But eventually you guys will vote for me, right?
I would.
Not when you hear what I'm going to do. Because what am I going to do? How am I going to get rid of the debt? I mean,
Make us pay it.
of course. Hello? You're all getting a bill, folks. And the bill is that number divided by that number.
60,857.
Am I using my calculator?
So how would you calculate this out using your calculator?
Away all the zeros?
Yes! Note, folks. So take 21,300,000,000,000 and write it over 350 million. I mean, don't punch all those zeros in your calculator. Use your brain. You know what to do with the zeros at the end of this fraction, right?
6 on each one.
So at least lop off 6 off of each one so that the numbers are at least relatively easy. And again, you can take one more off if you want and say 213,000,000 divided by 35. And that number you can actually punch in your calculator and see. How much do you guys all owe? What was that number again?
60,857.
27? That's per person.
14 cents.
14 cents? Oh, I wouldn't want to overcharge you.
Okay, when you're talking about, $60,000, that extra, 7 cents or
Well, we'll have free schooling, so it'll be okay.
Right, yeah, exactly. That'll be perfectly okay. Remember, this is each U.S. citizen. How many of you have kids? Guess what? You get a bill for every one of them, too.
Can I give my kids away?
Absolutely you can. No one's going to take them if they have to pay an extra $128,000.
So anyways, folks, just realize that, yes, when you start to figure out these large numbers divided by large numbers, okay, I like those sorts of questions. I want you guys to become a little bit more comfortable with numbers like $21.3 trillion, right? current business today, what's been happening in the business world right now, is that a lot of the small businesses and medium-sized businesses are being bought by the big ones, right? When business goes really well, what actually happens is that the big companies make buttloads of money and they have nowhere to put it. And so what they do is they say, ooh, here's a small to medium-sized company that's doing the same thing I am. Instead of competing with them, what are they going to do? Buy them, and then they don't have to compete with them anymore. And that's what's been going on, right? You're seeing the sort of the merger and conglomeration of lots of the different big companies out there. And that's one of those things that always makes me a little nervous about our sort of capitalistic society, right? In theory, though, folks, if there's only one company that's selling you something, what are they called? They're called a monopoly. What can the U.S. government do to a company that's a monopoly? They can regulate the crap out of them, folks. In theory, right? I mean, that's what happened to AT&T. What was it, like 26 some odd years ago? They used to be the largest telecommunications company around, and the government said, oh my goodness, you guys have become too big, and they split them. And that's where we got the 3 telecommunication companies that are out there right now. And guess what those 3 telecommunication companies have been doing the past 5 years? Trying to figure out who's going to buy who, right? Because they're competing. And what does competition do? Well, it lowers prices and reduces profit. What's the only thing business cares about, folks? No. They care about their workers, right? Anyways, all right. So please, again, be able to handle, some sort of a weird number, right? So if I give you this value, what is that number?
4,570 million.
$4,570,000,000. Please be able to write it out, right? So the decimal point becomes a comma. Any numbers after it just get put in. Add zeros based on that letter, right? T for trillion, B for million, M for million, B for billion, M for million. Note K technically for thousand as well. They do that, although that's not very common, right? Billion, million, thousand, hundred. Billion, million, thousand, hundred. So 4,570,000,000. And again, it's got a label, make it that label. All right? All right, so let's see. Oh, okay. This one, this is just to remind you. I'd like to think you guys all know this one, but so simple one to start with.
4,700.
Yeah. Just 4,700 or 4,700 colloquially. Add zeros at the end of it. Please be careful though. Technically, what are you really doing when you're multiplying by 100? You're moving the decimal over however many zeros there are in the number, right? So technically, there's 2 zeros, so hop this decimal 2 times. If it doesn't get all the way to the end, that's fine. All right? So don't just slap zeros on the end. That's 5th and 4th and 3rd grade. You're not there anymore. All right? And then likewise, if you go the other way, if you divide by 100, since multiplication and division are opposites of each other, when you multiply, you move it to the right. When you divide, you move it to the left. 2 hops to the left, boom, 0.416. All right? And again, don't freak out about this. Yeah, I mean, if the decimal point's up, don't just start moving it to the right because that's the only way it can move, all right? So it's division, it still moves 2 to the right. This number is just getting smaller. Okay, just the rules always apply the way they apply, okay? All right. Last thing.
No.
We really want to say no, right? But you know it happens, right? And you guys all deal with this, every single one of you. At least probably once a week, if not twice a week. Where is the number one place where you see decimals and fractions together? Kinda, yeah, but stores are actually not so bad about doing it. It's another place that's more traditionally started. Gas stations. How much does a gallon of gas cost right now?
$3.65.
That's if you're buying the premium.
I was about to say, what kind
Or
of
$2.65.
I was like,
I work at a
your
gas
gas is
station.
expensive.
I work at a gas station. I'm at
You're
$2.
slipping an extra $1 per gallon. Is that what you're saying? Okay, I
That's my
understand.
tip.
What gas station do you work at?
A gallon of gas, at least in the gas station down the street from my house, is $2.74 and 9/10 of a cent tacked
That doesn't make sense.
on. Every gas station has the 9/10 of a cent tacked on their gas. Why? Because they can.
Why wouldn't they just add an extra percent?
Well, why would you, right? This is not $2.75 a gallon, right?
Right.
It's only $2.74 a gallon, unless you actually look at the fraction and then see that, yeah, it really is $2.75. The reason why they started doing this, folks, is that, believe it or not, there was a time when gas was less than $1 a gallon.
And they didn't want to put $1 on there. So
They did not want to put $1 on there. Yes. When they had to raise it up to almost $1 a gallon, they tried to figure out a way to do it without putting the dollar in there. Because what they discovered is when they raised the price of the gas from 99 cents to $1.01 per gallon, the number of people that quit buying gas, I mean, they saw an 8 to 10% decrease in demand in gas because of a 2-cent increase in the price. The country went berserk, right? Because gas was $1.01 per gallon. Can you imagine that? I was livid. Exactly. I'm never driving a car ever again. Hello, get me an electric car. Oh, wait, yeah, those didn't exist. But the idea was that they said, okay, we can add this 9/10 of a gallon on, 9/10 of a cent per gallon, so that people don't have to worry about this extra real penny. And of course, this is, it makes people think it's only $2.74 because, folks, as Americans, when we read a fraction, guess what we do? Yeah, we almost always ignore it.
People always ask me how much it is, and I always say $2.65.
Right, yeah, you say $2.65, even though it's $2.65 and 9/10 of a cent. You're lying. It could get in trouble. Now, how do you deal with this, right? How does the gas station charge you for $2.74 and 9/10 of a penny when you buy per gallon? And let's suppose yesterday I bought 10.87 gallons. What was the price I paid? Here's the kicker, folks. The way the gas station calculates the price is it's not 2.74. They just take 9/10 and slap that onto the end of the decimal. So what is 9/10 written as a decimal? 0.9, right? So just take that 9 and slap it on the end of the 274. So this will really be 2.749 times the number of gallons that you purchased. And yes, this would be a calculator question on the test, folks. I would not ask you to multiply those two numbers by hand. That would suck. And so the calculator is going to tell you that that's how much you owe. Now, is that how much I'm going to pay? No, because what does money always get rounded to? We do round to the nearest penny. And note, folks, that gas stations must round correctly. So, what should my bill be for this amount of gas?
2188. I mean 2988.
$29.88. And if you would ever like to play the lottery without ever having to buy a lottery ticket, this is how you do it. Print your receipt at the gas station. If this is what you get when you multiply the number of gallons times the price, and they charge you $29.89, they incorrectly rounded up, that is an FCC violation by the gas station. And that is worth in a class action lawsuit between $15,000 and $40,000 per person who has a copy of a receipt from that gas station. And the gas station does not pay, it's the parent company of the gas station. So Mobil, BP, the guys that have so much money they don't even know what to do with it. So giving you $15,000 is like, dropping a quarter.
$5.
Yeah, exactly, right. For them it's no big deal. But if you can find one, it's happened twice that I know of. Once in Texas, once in Alabama. It's never happened in the north that I know of. But technically, if they don't round correctly,
How many people do you think actually check that?
oh good Lord, nobody.
Nobody.
Nobody. But I do about once every month or so, maybe twice a month. I'll check. I'll say, print the receipt, and I'll look at my calculator, punch it out, and go, damn. Right? Because if they round wrong, you bet there's a class action lawsuit coming with my name first, folks. Because I'm going to be on that lottery train like there's nobody's business. Okay? So, now, this is how it works, right? You just slap the 9 cents at the end. Now, the way gas stations really learned this, they didn't actually learn it from anybody in the business world. Where they actually learned it was from the farming industry. How many of you have ever woken up at 4 o'clock in the morning and listened to the AM radio so that you can get the farm report? So you know the guy who's doing the farm report at 4 o'clock in the morning? He's been doing it for 5,000 years. He starts every day, gets on the radio, and he goes, "Morning, everybody. Welcome to the farm report. It's Earl here. Corn up 1.5 cents per bushel. Soybeans down 2 3/4 cents. Wheat, oh my goodness, up 5 1/2 cents. They are dancing in the wheat streets today, folks." Right? I mean, that's. If you ever need to go back to sleep at 4 o'clock in the morning, turn on the AM radio, and that guy will put you to sleep. I worked one summer at my uncle's farm in Iowa, and that's what we did every morning at 4 o'clock. Right before we went out to the to work the fields, you'd have to listen to the farm report guy. It's 4 o'clock in the morning. You're eating breakfast, and you're listening to someone who could basically, put you to sleep. Oh God, it was so bad. But of course, if you're a farmer and you're listening to that report and you're growing wheat and you hear that wheat went up 5.5 cents a bushel, guess what you're doing?
Jumping up and down.
Yeah, these guys would be like, "Whoa!" And I'd be like, What happened?" Anyways, yeah. So that's what started it, folks. Was actually farm reports, right? Corn goes up 1 3/4 cents per bushel. How do you write 1 3/4 cents in dollars? .01.
No.
What's 3/4? 7.5. So this is how much money times however many bushels of corn you are growing that you are going to earn extra because of that 1 3/4 cent increase, right? And so this is really who taught the gas stations to do it, was the farmers. Right? So the farm reports have been dealing with quarters, eighths, even 16ths of a penny for decades. All right? They're the ones who taught it to them. So if you ever get mad at the gas station, don't get mad at the gas station. Get mad at the farmer who is next to the gas station. They're the real ones. Just kidding, of course. All right? So anyways, folks, that is chapter 3. For Thursday, we will go over the Chapter 3 homework. You will get your 3 freebies. Technically, the Chapter 3 homework will be not due until Tuesday of next week, but I would really love it if you turned it in on Thursday. Okay? So what's a week from today? The 11th? Is it really the 4th already?
Yep.
And does anybody know what numbers we went up to? Is it like 86 or something, or 64 or
84.
84? 2 through 84, the evens. And as always, the challenge problem is extra credit, but you do have to show all of your work to get any extra credit. Okay? There you go. Have a good Tuesday, and I will see you on Thursday. And I need to turn the camera off.